All right, do you see the questions now? Do you see the questions on my screen? All right, thanks. Well, let's go through each question. I'll give you a couple of minutes to think about it. Let's look at question 1. Calculate the limit as x tends to infinity of sine e power minus x and explain why this is true. How would you approach this question? How would you approach? Anyone? What's your answer? Do you hear me? Like, can you hear me? Hello? Hello? Hello, can you hear me? Okay, thanks. Okay, how would you approach question 1? Use the concept of composite functions. Limit of composite functions. Look at page 104 of course reader. So this is a function of a function, so sine of another function. So what you need to do is compute the limit is infinity of e power minus x first. Yeah, what's the limit of e power minus x is x tends to infinity? Okay. This is equals to 0. Okay. That's the first condition of that theorem, or definition. Then check whether f of x, f of 0 is continuous. So is sine of 0, sine of 0 is continuous. Then limit, this is equal to sine of 0. What is sine of 0? Yeah, 0. Okay, so that's what the definition says. So it's not definition, it's theorem. Which one? Look at theorem 23, maybe 2.3, but check it. Okay, page 104. So what that means is you should first find the limit of the inside function and then check whether the outside function is continuous at that limit. And then if that's so, limit of x tends to infinity of sine e power minus x is sine 0. Okay. There's any questions? By the way, you can plot this just to check. In your exam, in your quiz, you don't need Mathematica, but I am using it here just to check whether this is okay. Sine of exp x is x maybe -5 to 10. I think I have written -6. Yeah, so it goes to 0. All right. So that's the first question. Is that okay? Do you have any doubt? Let's look at the second question. What is this limit? One over cos x plus x. What is this limit? How would you approach this? Anyone? Is it divergent? Why? How is it? Why? Zero. Kai, why is it zero? Okay, cos function oscillates between 1 and -1. X dominates the denominator. Yeah, that's a good observation. +1. Okay, then you could add a x plus x. Then you could say for x bigger than 1, because we want it to be infinity. Okay, you have 1 over okay, so that's true. Okay, now how would you approach this one? You have this function in between 1 over 1 plus x and 1 over x minus 1. Okay, what sort of approach do you use? Anyone? Let's have a look at these three functions. Maybe you will get some ideas. Okay. So the original function 1 over cos x plus x is in the middle. On it's bounded above by 1 over x minus 1 and below by 1 over x plus 1. Okay, what do you call? Yeah, Kai, that's good. So when the function is in between these two other functions, then you would take the limit of the left-hand function and limit of the right-hand function. And if those two limits goes to the same value, then the limit of the middle function should also goes to the same value. Okay, so that's how you should approach. Okay, so we have then by the squeeze theorem. Okay, does that make sense? I assume yes. These are the type of questions that you would. I'm not sure if exactly these types. Okay, but I've been given the guidelines. Okay, so I'm assuming these are the types of questions. Okay. Is limit x goes to infinity. Okay. Is that clear enough? Is there any question regarding this part? Actually, you don't need to draw anything, but just proving like this should be okay. Okay, I have drawn it here just to make sure that you understand what's going on. All right, let's go to question 3. Continuous functions. Consider the function sine x over x when x is positive, and 1 when x is less than or equal to 0. Show that this function is continuous for all x. How do you approach this? Yes. Okay. So when you look at, yep, Kai, you're on the track. So in your course reader, you must have come across 2 types of continuity. That is continuity at a point. Okay. See page 104. No, page no, this is not page 104. This is section 6.4. I think this is definition 12. Okay. Then have a look at continuity interval. Okay. Page 104. Look at this. How would you use that? When x is less than 0, do you think the function is continuous everywhere? Yes. When x is positive, is the function continuous everywhere? When x is positive, is this function sine x over x continuous everywhere? Is sine x continuous everywhere? Anyone? Sine x should be continuous. Sine x divided by x when x is positive is also continuous. So fx is continuous. Everywhere except possibly at x equals 0. Then we check whether this is continuous at 0. Okay. Okay. There are some conditions that you need to check in that theorem. Continuous at a point, definition 12. Okay. The first one is check if f of 0 is defined. Is it defined? Yes. Okay. The second condition is check if limit of fx exists as x tends to 0. Is that true? Third one is check if limit equals f of 0. Okay. How do you check this one? The second condition, is it defined? Yes, the second condition is the limit, does the limit exists as x tends to 0? You can check limit from the left. If x is less than 0, is what? If x is, if that is limit from the left. Sine x over x. What is that? What is the limit of sine x over x? 1. Yep. It is also given in your lecture notes. Okay. Therefore, exists. Okay. Now the third condition, check if the limit of fx is f of 0. Is this true? Yes, is f of 0 equals 1, which is limit x. Okay. All right. So that's question 3. Is there any question? Do you have anything to clarify? Anything? Okay, I'll give you a little bit time to think about question 4. Intermediate value theorem and mean value theorem. What is intermediate value theorem? What does it say? How would you apply, how would you show that the function x to the power 4 plus x plus 1 does not cross the x-axis? Any ideas? Yeah. It shouldn't have a root when x equals 0. Yeah, if x equals 0, that's also correct. But how would you show that? Kai says find the minimum and then say check if the minimum is positive. That's exactly what we that's the approach that I would use here. So maybe you can do this. Step 1. So for x in f dash x equals 0, what is that x? What is that? Then how many solutions does it have? Step 2. Find f double dash x. What do you conclude? Okay. Step 3. All right. Okay, step 3, I will say when you give me this one. Okay, solve for x in f dash x equals 0. What is f dash x? What's the expression for f dash x? Yeah, 4x cubed plus 1. Okay, equals to 0. How many solutions did you get? Yep, you should get one solution. Okay, that is x equals, you would get cube root. Oops. Minus 1/4. Okay, something is going wrong. I did this previously. Let me check. Yep, just one root. Now find the second derivative. What do you conclude? F double dash equals what? Twelve x squared. Okay, what do you conclude about the critical point? Which is always positive. Okay. Is a minimum. Okay, now find f of your critical point. What is it? Okay, which I got it as positive as well. Okay, so that means there's only one minimum, and which is global. So, and then the value of f at that point is positive. Okay, above 0. Therefore, okay. Part B. Is there any question from that part? Part B, consider the new function. Show that there are exactly two functions, two solutions to fx equals 0 using the intermediate value theorem and mean value theorem. What does intermediate value theorem says? How would you use intermediate value theorem in this case? Can you look at it? Page 105. How are you going to use intermediate value theorem in this case? Okay, to take two values A and B. What are the two values? Okay, step 1. Use the intermediate value theorem. How many roots? Okay. Yep. So intermediate value theorem says if you take 2 points, if you take an interval and then compute f of A and f of B, and the values are different, and if f is continuous between those 2 points, then there must exist another point in the interval such that f of c equals f of c is there must exist another point such that f of c is within f of A and f of B. Okay. Let's look at this. What is f of 0? In this case, what is f of 0? should be easy. What is f of 0? Look at the function. Sub-zero here, that is -1. Okay? And then what is f of 1? One. Okay, what is f of -2? 13. That means so by the intermediate value theorem, there exists at least 2 roots. Okay. Okay, now use use the mean value theorem to show that there is exactly 2 roots. How would you do that? Suppose there are at least 3 roots, 3 distinct roots. Say x1 less than x2 less than maybe x3. Okay. Then there exists number c in the interval x1 to x2 such that you have f dash c equals 0. Okay. That's by the mean value theorem. And there exists a number d in the interval x2 to x3 such that f dash d equals 0. Okay. Now, what does that mean? Okay. Now, the actual f dash x is equal to what? For x cubed plus 1. Okay. But this gives us x equals what we have got previously, -1 cube root of -1 to the power 4. Okay. only one root. Okay, so which contradicts? Okay. Okay, does that make sense? So you prove this by contradiction. Any question? Let me quickly go to question 5. This is the sum of n to the power 2 over e. Does this sum converge or not? What do you think? Does the sum converge or not? Anyone? Converge? Converge to what? Okay. No. Let me share my laptop's iPad screen. Okay, you can think of by applying the p-test. What the p-test says that if the sum, if p is a real number, well, sum of 1 over n to the power p converges if p is bigger than 1, diverges if p is less than or equal to 1. You can rearrange this to 1 over n to the power minus 2 over e, which is minus 0 point something. So it's less than 1, so diverges. Okay. And then for part B is you can apply geometric series concept. In that concept, you have a r to the power n converges if r is between minus 1 and 1, diverges otherwise. And in this case, you got a equals 1, r is pi minus e, which is 0 0.4, less than 1. So it converges to 1 over 1. A is 1, so it's 1 minus r. Your r is pi minus e. So it converges to this value. Okay. Does that make sense? Any questions? Any questions? If no questions, let's stop.